So this is separable equations unit. In this subunit, we are going to discuss how to solve separable differential equations. First, we need to recall what is the separable differential equation. It's an example of differential equations where the variables in the equation can be separated. So, in solving this kind or this example of differential equations, the first step is to regroup x dx in one side and y dy in the other side, so that I can integrate both sides of the equation. In order to integrate, I need x dx in one side, y dy in the other side. Then we do the integration using the different methods of integration, like substitution, integration by parts, trigonometric functions, and so on. If there is an initial condition exists so that we can substitute the appropriate value of x and y in the function, and we can solve for the constant. As we know, as a result of the integration, we will find a function with constant. So if we have an initial point given in the question or in the problem, then we can solve with the constant. If we don't, so we'll be done. Let's take examples and apply these steps to solve separable differential equations. In this example here, dy over dx plus 2xy equals to 0. Now the first step is to differentiate or to separate both terms of x dx in a side of the equation, y dy in the other side. So dy over dx plus 2xy equals to 0. I will move this term to the other side, so take away 2xy from both sides of the equation. So now dy over dx equals to 2 minus 2xy. Now still the left side and right side, both of them have x and y, so I need to get rid of this dx from this side. Multiply both sides with dx. And in order to get rid of y from this side, divide by y. Also both sides of the equation. Any operation, any mathematical algebraic operation done on one side of the equation has to be done on the other side in order to keep the equation balanced. So I did multiply dx over y for to both sides of the equation. So here I get rid of y from this side, and we get rid of dx from this side. So I have 1 over y dy equals to minus 2x dx. Now we separate the terms of x dx and terms of y dy in each side of the equation. So now I need to integrate both sides of equation. Then when integrate both sides of the equation, then 1 over y, the integration of 1, the inverse function is ln the absolute value of y, now equals to minus 2 x squared, as the integration of x is x squared over 2 plus c. Now here we will have as a result for the integration ln absolute value of y equaled plus c1 and here plus c2. I take the constant from this side to the other side. Now we have c. c is c2 minus c1, as they are all arbitrary constants, so it's okay to add or subtract the constant and it will give me a constant too. Now ln the absolute value of y will equal to minus x squared plus c. In order to get rid of the ln, we will raise both sides to the exponential. We'll take the exponential of both sides, exponential ln y equals to exponential minus x squared plus c. Now the exponential of the ln absolute value of y equals to y. Now absolute value of y equals to the exponential of minus x squared multiplied with the exponential of c, the exponential of c. Now this term is a constant too. This term is a constant. Exponential c is a constant, let's call it c3 for example. So the absolute value of y will equal to c3 multiplied by the exponential of minus x squared. To take away this term, the absolute value of any term equals plus or minus of c3 exponential x squared, and this is the solution. Now we solve the differential equation, we got the function y in terms of x. Now since there is no initial condition imposed in this problem, so we are done. Let's take another example. dy over 3y plus 2 equals to x squared minus 4 dx. This equation, as we notice, all the y dy terms in one side, so it's separated already, no need to separate the variables in the equation. It's ready to integrate. So all we need to do, directly we will integrate both sides. Now in integration for this term, we will use the method, substitution method. So how? I will assume, so let a new term y equals to 3y plus 2. So du, I will take the derivation of u to y, du over dy equals to 3. So dy equals to du over 3. Let's substitute this term here. Now what is happening here is I have instead I will substitute dy with du over 3. Then we have du over 3, and instead of 3y plus 2, this value 3y plus 2, which is u, equals to the integration of x squared minus 4 dx. Now let's integrate. I have 1/3 outside, the integration of 1 over u du, this is inverse function, and have the integration of x squared minus 4, this dx. So I have here a third, it's a constant. The integration of 1 over u equals to ln the absolute value of u, as we all know, plus c1, a constant. Here the integration of x squared equals to x cube over 3, or third x cube, minus 4x plus c2. Now I will take all the constant in one side. I will take c1 here to the other side. I will have c2 plus minus c1, which equals to another arbitrary constant. Let's name it c3, or let's name it c3. Okay, now 1/3 ln the absolute value of u equals to 1/3 x cubed minus 4x plus c3. I'll multiply both sides with 3, so ln absolute value of y u equals to x cubed minus 4x, no, 4 multiplied by 3 is equal to 12x plus 12c3, let's call it, or let's define another constant, let's name it c4. I don't want any coefficients multiplied with the constants here. It's constant whether it's raised to a power or it is divided or multiplied with another constant, it remains constant. Just change the name. Now ln absolute value of u, I will take the exponential for both sides. Now let's substitute the value of u again, ln absolute value of 3y plus 2 equals to exponential x cubed minus 12x plus c4. Let's proceed. Now the exponential ln of any value equals the absolute value of it, 3y plus 2, now equals to exponential c4 multiplied with exponential x cubed minus 12x. Now the absolute, okay, let's define a new constant here. Exponential c4 exponential, a constant is a constant. Let's define a new constant, name it c, then c2, c multiplied with exponential x cubed minus 12x will be equal to the absolute value of 3y plus 2. Now I want to get rid of the absolute sign, so the absolute value here equals absolute value of 3y plus 2 will be equal to minus or plus c exponential x cubed minus 12x. Now take away minus 2 from both sides. 3y equals to minus 2 plus or minus c exponential x cubed minus 12x. Now divide by 3 both sides. Now y will be equals to minus 2 plus or minus c exponential x cubed minus 12x over 3. Now we don't have any initial conditions, so we are done to this point. If any initial condition given, for example, give you the initial y of 0 equals 1, then you take the 0 and 1 point and substitute it here in the last function y of x. Then you will solve the c. You will get the c and rewrite the function with c.